What is IPv6? IPv6 is an abbreviation of the term Internet Protocol version 6. But to understand it, we first have to understand what the term Internet Protocol is. In computer terms, a protocol is a language, and if computers wanted to speak to each other, they'd require a common protocol, or a common language. Just like how if you wanted to speak to a friend, you need a common language, otherwise it'd get really hard to speak to each other. So the term Internet Protocol, as the name implies, is the protocol or the language of the Internet. And at the moment, we're using version 4 or IPv4. So what's the big deal with this new version of IP or IPv6? Let's take a little history lesson. In 1977, while the Internet Protocol as we know today was being designed and engineered, a man named Vincent Cerf made a very important decision. He decided that the addressing space of the Internet Protocol would be 32 bits long. Now a 32-bit number is pretty large. It can accommodate up to 4 billion individual computers on the network. And so he reasoned that it was enough. Now in his defense, they were designing the Internet Protocol as an experiment for the US Department of Defense. Vincent thought that even the well-resourced US Department of Defense would never be able to create 4 billion computers on their own. What Vincent didn't realize was that IP and its 32-bit addressing space took off and became the default protocol for nearly every network on the planet, including the biggest network of them all, the Internet. Suddenly, 4 billion addresses didn't seem enough. With 7 billion people on the planet, and most people in the developed world having more than one computer on the Internet, 4 billion addresses were drying up. So computer engineers the world over had to address the problem by introducing a new version of the Internet Protocol, IPv6. IPv6 has an addressing space of 128 bits rather than just 32. This means that instead of being able to support just 4 billion addresses, IPv6 can support, are you ready for this, 340 undecillion addresses. To put that in perspective, that's nearly 400 trillion addresses for every cell of every human person on the planet. I think that's enough. Now sure, IPv6 has more than just increased addressing space over IPv4, but that's the main reason we're moving to the new version of the Internet Protocol. Unfortunately though, unlike IPv4 that can be expressed quite easily with the octet system, IPv6 addresses are just too large to be compressed into easily identifiable chunks. So the usual notation of displaying an IP address in IPv6 is as 8 groups of 4 hexadecimal digits. Hexadecimal digits can have values of 0 to 9 and A to F. In other words, they have 16 possible states rather than just 2 for binary or 10 for decimal. Another unfortunate thing about IPv6 is that it's not backward compatible with IPv4, which means that old modems and routers that support only IPv4 can't work with IPv6, and that's slowing down its adoption rate. Well, why didn't engineers just invent a variable length addressing space? Wouldn't that be easier? No, the Internet works on speed, and if routers had to spend even a fraction of a second unpacking a packet to find out the IP address, that would slow down the entire Internet. So a fixed length of 128 bits was chosen, and out of it was born IPv6. So just to recap, we're currently using IPv4 that has 32 bits addressing space, and we're moving to IPv6 that has 128 bits of addressing space, and the reason why we need that is because we need more space on the Internet.